Good morning, everyone. It's 10 o'clock. I'd like to thank you for joining us. My name is Nathan Heston, and I'm joined by my colleague, Daniel Moyer.
Good morning, Nathan.
Good morning, Daniel. It's a beautiful morning here in California today. What we have for you today is a course on Battery Chemistry 101. This is really the basics. Again, my name is Nathan Heston. This is a NABCEP accredited course. And so if you're here for continuing education credits, please stay through the end. You need to stay for the whole period of the training. It's a 1-hour training, and I'll provide my email at the end, and you can email me your name as you would like it to appear on your NABCEP certificate, and we'll get those certificates emailed out to you. It typically takes about 1 day to process all of them, so you should be getting that tomorrow. You'll also be receiving a recording of this presentation. And if you have any questions, please feel free to use the Q&A feature of Zoom. So you should see a Q&A on your Zoom menu there. We don't have the ability to unmute during the webinar, but we do have the ability to answer those questions. And Daniel will interrupt me if there are questions that we should answer live, and he'll try to answer some of them in real time. So let's go ahead and get started. First thing to mention to you is next week, we have additional training opportunities. We have a booth at 5554 at RE Plus. And so if you're going to RE Plus in Las Vegas this year, it's just this next week. We have a series of trainings that we're offering. Daniel, you're offering a training similar to this related to using our PHI batteries.
Yeah, exactly. I'm going to be talking about upgrading off-grid systems to lithium-ion batteries. So we have our PHI battery. It's our non-communicating battery that still leverages lithium iron phosphate chemistry with the cylindrical form factor. And we're able to pair those, right? Take out old lead acid batteries and then insert these safe lithium-ion batteries that have amazing cycle life to then get your homeowners back onto their daily off-grid lives.
So thank you, Daniel. So look forward to that. If you're coming to NABCEP also, I'll be giving a couple of trainings. One of the trainings that I'll be giving is just energy sales made simple. And one of the things I'll be highlighting is how we have these energy backup packages to make understanding backup power with batteries easy for the homeowner. And we explain in that presentation how much backup time you're going to get from lithium batteries, why lithium batteries are so much better at giving backup, and what critical loads are, what demands are in a typical home. I'll also be doing a joint presentation with Dylan Hillman from Solarc, and we'll be talking about how to use our Briggs Stratton battery packages with our different Solarc offerings that we have. And our batteries pair well and use communication with the Solarcs. And then we also have a talk on Thursday by our boss, Sequoia Cross. She'll be talking about the value proposition for software and apps with energy storage. So please stay tuned. If you are coming to RE Plus, visit us. We'd love to see you, and we'd love to get questions there. But one of the things you may or may not know is that Briggs Stratton has purchased SimpliPHI Power a couple of years ago. So SimpliPHI Power is kind of a legacy company at this point now. Briggs Stratton purchased us a couple of years ago, and we're now producing these batteries under the Briggs Stratton name. So you might see a little bit of the SimpliPHI logo appearing in some of our photographs here. Briggs Stratton, of course, is a long-standing 115-year-old U.S. company. SimpliPHI Power has existed previously since 2010, perfecting LFP battery storage for home use. And to put that in perspective, Tesla came out with their Powerwall in 2015. So we've been doing this a long time in terms of home battery storage, and we're one of the original manufacturers of LFP battery chemistry here in the U.S. So we assemble our batteries in Oxnard, California. A lot of drivers, a lot of reasons why you might be on this webinar today. There are a lot of drivers for storage being added to solar and just homes for backup. We're not going to go through these in detail. We hit these almost each one of our presentations, but people are spending more and more time at their homes, and they want reliable access to power. And of course, there's a strain on the existing infrastructure in the country. We get more power outages. So we have had increasing power outages over the past 10 years. And that has to do with an increasing demand for electricity as people consume more and more electricity. And things like vehicles moving to electric, right? So that puts more of a strain on the existing infrastructure. And so more people are choosing backup for many of these reasons. Of course, we can't forget that clean energy and climate-related disasters have also been on the rise, and people are wanting to be part of the solution and not the problem by switching to clean energy. So the home battery market is supposed to expand to reach about 6.6 billion by 2027. So there's a lot of business opportunities for installers to increase their repertoire and start offering battery storage. And so we're going to get you started with that today. In line with that is this fact that we're not going to give you tons of statistics today, but one of the things I do want you to leave with is that only about 11% of homeowners that have solar currently have 11% have batteries, and about 33% are expected to have batteries by 2027. And that's driven by a number of things that I mentioned earlier. In California here, Daniel gave a presentation yesterday with Solagent, speaking about why NEM 3.0 really makes battery storage a smart move financially. And so if you didn't catch that, I encourage you to check out that on the Solagent YouTube channel. Yeah, solar battery installations are expected to rise. Daniel, go ahead.
No, I was going to say that's exactly right. Josh Brum over at Solagent, we had done an amazing NEM 3.0 talk, and he has other ones, so you can check out their YouTube channel. And one of the things I want to mention is that even if you have somebody under NEM 2.0 or perhaps even NEM 1.0, you can still add energy storage to their existing system and have them stay under that same older, more favorable rate. So exciting to see that coming forward. Additionally, with the tax incentives now, anywhere in the country, you can now add storage, standalone storage to a home and have the homeowner still leverage that 30% tax credit. So there's opportunities out there really to add is storage only.
These are great points, and I think a lot of these types of questions are the things that homeowners are going to come at installers with. They want to know, hey, I already have solar. I don't want to get off NEM 2.0. I heard the rates for NEM 3.0 are unfavorable to homeowners, but I still want that storage. Can I keep my NEM status? And that's exactly what Daniel's just saying. Yes, you can. You can add battery storage and keep that status. And not only that, you can leverage that 30% off tax credit. You can even do that with battery alone. Battery standalone equipment, even without having a renewable energy source. And that didn't used to be the case last year. So what are applications for batteries? Backup power, of course, is this one that most people understand. If they have batteries there, they can potentially back up their whole home if they have a large enough battery system, or at least back up critical loads. They can also save some money on their utility bills. One of the things that I do with the system that's behind me is I discharge this during the evening. So I'm storing up that energy that's coming in from my solar panels during the day, and then I'm exporting that energy to my refrigerator and to a spa that I have here and to other loads that I don't want to be powered from the grid. So I can save some money that way. And storage plus renewables, of course, offers you that opportunity. I like to describe solar panels as energy pumps, right? You have to invest in the pump, but once you have that pump, you can pump as much energy that's coming for free from the sun into your loads. And if you have more energy coming from that solar array than your loads, then you can store that. And so pairing storage with renewables makes a lot of sense, especially as the cost of solar panels has drastically decreased over the past few decades. Of course, there's this off-grid application for storage, and many people got started in the off-grid market. Off-grid market was really the driver for early solar adoption, where people would typically have batteries and lead-acid batteries, and we'll get into that a little bit today. And then there's generator optimization. So you might not know this, but if you are running a generator, that generator will produce power or produce electricity at the most efficient rate when it's run a little bit on a higher load. So when you load your generator around, Daniel, would you say it's 70 to 90%?
It's about 70%. And one thing I want to mention, I'm glad you brought this up, is that we actually, our next training, which is going to be September 21st, we are going to spend the entire hour talking about this exact subject, that Briggs Stratton Energy Solutions not only makes energy batteries, home batteries for your home, but we also make a line of standby generators that both run off natural gas and propane, some of the most powerful air-cooled generators on the market that don't derate on natural gas. So exactly, you want to run them at a more fuel-efficient point. And stay tuned, SimpliPHIpower.com training calendar. You can register for that upcoming September 21st training.
Thanks, Daniel. And just to remind everybody, what we were saying there is, right, if you're running your generator at a heavy load, you could be using that generator to power loads in the house as well as charge your batteries. And then you can turn that generator off sooner, saving yourself fuel. So there's some optimization there. So today we're going to get into the basics of battery chemistry, just the basics. This is not a full talk on chemistry, but I'm going to explain a little bit. There are a lot of types of lithium-ion batteries. It's not just one technology, right? And the variations in the lithium-ion batteries typically have to do with the cathode material. That's the positive side of the battery. So the lithium moves between the negative terminal and the positive terminal in the battery, and the electrons do the same thing through an external circuit. And so there are variations between the material used for the cathode in batteries, and many of these, as you can see on the screen, contain cobalt. And we are a cobalt-free chemistry. Instead of using a cobalt oxide, we are using a lithium iron phosphate. And so we're using iron instead. And iron phosphate is a relatively benign chemical that exists in our DNA, right? So we all have iron phosphate in our bodies. And cobalt is, there are several downsides to using cobalt in batteries. One upside is you get a little bit more energy density. So when you dope the metals in the cathode with some cobalt, it results in more energy and in higher concentration, and slightly higher voltage, which is what brings that energy density up. The downside to this is that cobalt's often a conflict mineral, and it's toxic, right? And it means disposal of the batteries and the toxicity of the batteries in the event of a problem. It even increases the likelihood of a problem. And because of these reasons, for home battery backup, I would never recommend somebody to use a cobalt-based chemistry. And I know some of our competitors are still doing this. Most people for home battery backup, most companies are now switching to safe LFP chemistry. Well, we have a history of developing LFP technology since 2010. We've been doing this. So we've got a long history of making LFP better and better and better. Batteries, not only do they have different chemistry inside the cells, but the cells themselves. So if you look on the right side of your screen, the cells that are used to build up the full complete battery module can be made in different ways. The cheapest way to do this is with pouch cells. And I would never recommend anybody to buy a pouch cell for home battery backup. It's most easily damaged of all of them. It's also the shortest lived. So we use a cylindrical cell, which is a steel cased cell. You can think of this kind of as like a AA or a AAA style cell. It looks like that. It's got a sealed steel case, and that steel case provides rigidity. Prismatic cells are another option. One downside to prismatic and pouch cells is that the expansion and contraction with heat can lead to a slightly quicker degradation. A prismatic cell is better than a pouch cell in that it's a rigidly enclosed plastic case, and that plastic case offers fairly good energy density, offers some savings in terms of production. But really the premium cell to be used is the cylindrical cell, and that's how all of our batteries are manufactured. So we're using lithium iron phosphate battery chemistry. This is the safest battery chemistry that there is currently on the market, and we're using cylindrical cells, which offers us the ability to give a long warranty because of longevity. The other thing about lithium iron phosphate battery chemistry is you get the most number of cycles out of your batteries. So I'm going to talk to you about if we discharge our batteries down to about 20%, so using about 80% of the capacity of a battery, we're expecting 10,000 cycles. If you divide 10,000 by 365 for one cycle per day, you get 27.2 years. So again, battery basics here for our Briggs & Stratton Energy Solutions batteries. We're offering LFP chemistry with cylindrical form factor in these builds. There are many of these cylindrical cells inside, and then we have different BMS units that we use for our different battery offerings. Because of this, on our communicating batteries, we can offer a 15-year warranty, and this is a true 15-year unlimited number of cycles. So we aren't saying, well, only if you do 5,000 cycles. We're saying unlimited number of cycles, unlimited depth of the cycle, so you can discharge this battery as deeply as you like, and you can do it as many cycles as you like. But this is on our communicating batteries. We have a full 15-year warranty. And after 15 years, the end of life capacity, we're guaranteeing 70% or greater. So 70% of that original capacity or greater after 15 years. Again, if you size these batteries a little bit larger so that you're only discharging them to 20%, we're expecting an even longer life than this. What is our C rate and what is the C rate? The C rate corresponds to how quickly a battery can charge or discharge. A C rate of C over 2 means that that battery could charge or discharge in 2 hours. A C over 4 would be charge and discharge in 4 hours. We have a fairly fast C rate on our battery. We charge it at a current rate of a C over 2. That means the capacity of the battery in 2 hours, which allows our batteries to provide a relatively high power output for limited size batteries. It also allows you to run that generator a shorter amount of time. If you're charging up in 2 hours, you want to be able to charge quickly and turn that generator off if you're doing generator charging. And these batteries are also capable of surging. A couple things to point out is that people often ask us about the safety of batteries and disposal, etc. So one of the things that is happening with lithium batteries is that a recycling market is emerging. Keep in mind that none of these batteries are landfill safe. We're pointing that out here. But the LFP battery chemistry that we use does not have a risk of thermal runaway. And I want to point out that the other ones do. These cobalt containing chemistries and even the lithium manganese oxide batteries, they have a higher risk of thermal runaway. And we'll get into that a little bit today. We also don't use cobalt, which can involve, and most of the cobalt is produced in the DRC, and it can involve somewhat questionable ethical practices to source. Also, some of these chemistries require ventilation. And so just pointing that out, when you're looking for home battery backup, really you should be looking for LFP battery chemistry, and most companies are going to be telling you that. What is thermal runaway? Well, thermal runaway is basically a chain reaction. So in the event that a battery is damaged, or in the event that a battery is maybe not constructed very well. Sadly to say, for Samsung, the Note 7 was recalled, and many of you might have recalled that this phone was actually banned on airlines. So you could not fly with your Samsung Galaxy Note 7. It was banned on flights because it would go into thermal runaway. Thermal runaway is a case where maybe some internal short circuit or a drop or an abuse of a battery will cause that battery to short circuit. And that short circuit, as you can see in this, I'm going to highlight it with my mouse, in this little diagram of a battery, when a battery is discharged, there's some internal resistance. And when it's discharged internally, right, maybe due to a short circuit, that internal resistance will cause heat to build up inside the cell. If that cell gets too hot, it can eventually rupture and give off an organic vapor that comes from the electrolyte, causing that vapor to potentially be flammable. If that vapor gets hot enough and catches on fire, a larger battery module could have an individual cell catch on fire, release heat from that fire to the surrounding cells, and cause those surrounding cells to go through the same process, essentially an unmitigated chain reaction. This is not a case, we do not have unmitigated thermal runaway with our batteries. That's one of the reasons that LFP batteries are so much safer, is that they do not go into unmitigated thermal runaway. And we have external testing that confirms this with our batteries. We actually, with our UL testing, Daniel, what do?
We simulate the worst case scenario. We take some of these battery cells and we wrap them in essentially a heating blanket, a wrap, and then we force them into thermal runaway. Additionally, I'm just going to keep plugging upcoming trainings, but we do have some upcoming trainings that go deeply into this exact topic. Coming up on October 5th, we will spend the entire hour talking exactly about these UL testings, and we're going to show pictures on how exactly safe these LFP chemistries are over some of these other cobalt.
Thank you, Daniel. So yeah, what happens is with a UL testing, we wrap those batteries, we force them into thermal runaway, and we publish the results of our tests. Our batteries self-extinguish, so we don't have this unmitigated thermal runaway that can happen. I just got a text early this morning talking to me about some Tesla cars that had caught fire with the last hurricane, and I think this was due to a saltwater flooding of the cars causing a short in the batteries. Now, those batteries should be sealed, but potentially on the underside of a car, some body damage to the car might have compromise the seal on those batteries. So I can't speculate as to exactly what happened with those batteries, but again, those are NMC batteries. And even Tesla has realized this, that they are moving their battery chemistries to LFP, and last year was the first year that more than half of Teslas were produced with LFP battery chemistry. One of the ways to know the difference between LFP battery chemistry and an NMC battery chemistry in a Tesla is if you are encouraged to charge it to 100%, right? So with this NMC battery chemistries, you're not supposed to bring them up to 100%. They don't last as long if you do. And LFP battery chemistry in general gets almost twice as long of the expected cycle life of NMC batteries. One last thing about thermal runaway is when thermal runaway does happen with NMC batteries, it releases heat very quickly. And so that rapid release of heat is what causes that thermal runaway to continue. This is a YouTube channel that there are videos where this guy, Will Prowse, punctures NMC batteries and LFP batteries. And you can see the big difference. He had to, in fact, puncture the LFP battery on the right multiple times to even get it to off gas, versus a single puncture of the NMC battery. It burst into flames almost immediately. And this is just a third party trying to highlight the safety. Again, when you're choosing batteries for home backup or even business backup consideration purposes, choose LFP. It's a much safer chemistry. Again, this is from a national lab, just confirming what I'm talking to you about, how LFP battery chemistry is safer. What is on the left side, this vertical axis here, is the normalized heating rate. This is how quickly, basically how quickly heat was released from a battery when it was forced into thermal runaway. And if you look at how big of a scale is here for NMC, NCA, nickel manganese cobalt oxide, lithium cobalt oxide batteries, they're on a much higher scale than LFP. If you look at LFP, it's actually just down on the axis. It's a very slow release of temperature, even when you force it into a thermal runaway. Again, this is from the national labs, Sandia National Labs. I believe that's in New Mexico, near Albuquerque. Again, if you zoom in, you can see the rate of heat production from an LFP battery cell, but it occurs at a much slower rate. You know, similar amount of energy, but it takes a long time to release it. And so it's a much less dangerous burn. If for some reason you were able to, or maybe, you know, the battery got damaged in some way, it's a much slower release of heat, a lot easier to deal with. Okay, so we've talked a bit about what a cylindrical cell is, about the safety of LFP chemistry. What's inside each of these cells are essentially that cathode and anode material I was talking to you about. The way a battery works is it has lithium that can move. I'm going to show you here between the cathode and anode material through a separator layer that keeps the electrons from doing that. If we blow this up, if we zoomed in on a cross section of, this is called the jelly roll. If we zoomed in on that, you would have an aluminum foil that makes up the cathode, and then you spray a metallic oxide. In our case, it's a iron phosphate for the metallic oxide. And then it's separated by a separator layer. There's an organic electrolyte solution inside there that allows lithium ions to move through. So it's basically like salt water in a way. It's a little bit more viscous and it's organic. but the lithium ions can move from one side to the other. They prefer to be in the metal oxide. So what we do with a charger is we pump the electrons through an external circuit. Those electrons move over to the graphite anode. So typically this is almost always graphite. There are a couple of cases of new batteries that are being developed where they don't use graphite, but we're not going to get into that. So essentially, we pump the electrons to the graphite side. The lithium moves over to rejoin their electrons. And then when we discharge a battery, we remove the charger, put a load here, allow the electrons to move over to the metal oxide, and they meet their lithium ions there and kind of reform. And so that's the driving force of these batteries. Again, we're just hitting the basics here. Want to point out that temperature does play an effect on these batteries. Typically, as a battery is charging or discharging, though, the battery will heat up. In extreme cold situations, you might have heard that you get less energy out of your batteries. And in extreme cold situations, the batteries can have a little bit reduced capacity. Now, typically what happens when a battery is charging or discharging, even though you might have very cold air surrounding it, the internal cells of the battery will start to heat up and they'll move to warmer temperatures, and the battery capacity will actually increase as it's discharging. And that might sound counterintuitive, but remember the reason for that increase in capacity just has to do with the end voltage of the battery. It's still the same number of ions that are inside. So keep that in mind. If you're discharging in extreme cold, you might want to have that battery in a heated enclosure. And if you're charging in extreme cold, below 0 degrees Celsius, the charging can actually be dangerous to the battery. So for this reason, we've outlined the temperature ranges for our batteries. Now, our PHI battery is a non-communicating battery. And what we mean by that is the internal computer in this battery, the battery management system, does not communicate with charging equipment. So it's got preset values in there that are there on the BMS to protect and balance the cells, but it cannot tell charging equipment how fast it wants to be charged and discharged, etc. And so the charging range for this battery is specified on the screen. The discharging range is a bit broader. The reason for the reduced charging temperature range at low temperatures especially is that the lithium can build up. It struggles to get into the graphite layer, which is what we're doing when we're charging it. On our more advanced batteries with our communicating BMS units inside, these batteries are able to charge even below 0 Celsius. They can charge all the way down to -20 Celsius, but at a greatly reduced rate. And they slow that charging rate down. And as that battery heats up with the charge cycle, we can increase that rate. And so for this reason, we have this kind of gray area on the charging window for our communicating batteries. And I'll show a little more detail here. So the charging rate that this communicating battery tells compatible equipment like a Solar or one of a Briggs Stratton inverters, right? It communicates that this is an AmpliPHI battery. It's one of our product lines that we're going to get into. But this battery communicates that it wants to be charged at its maximum charging rate of 37.5 amps between the range of 70 to 50 Celsius. And normally this is where this battery would be sitting. But in extreme cold situations, let's suppose we're at -15 Celsius, that's down at below 0 or around 0 Fahrenheit, right? This battery will communicate that it only wants to be charged at 1 amp. And then as it starts to heat up, it'll increase the charge rate. It'll say, hey, now charge me at 3 amps. And as it gets even warmer, as it gets into that range from 0 to 7 Celsius, that's around the 32 to 38 Fahrenheit, it'll increase to 20 amps. And then it will get itself within the optimal window for charging. So that's one feature. And again, Daniel, you want to plug another training here? We have a whole training on this.
Yeah, we absolutely do. We talk about environmental ESS and environmental considerations. And I think this is becoming more of a concern as these energy storage solutions are starting to be installed in other parts of the country who really hadn't seen this kind of been adopted before. Usually it's the Californias and those other kind of locations. So I'm really excited to see some of these solutions coming to the market. Nathan, Let me ask you this. So say for whatever reason I do charge it above the amps that are recommended in this chart, what happens to the battery? You explained that it has difficulty migrating. Does the battery catastrophically break, or what happens if we don't listen to this chart?
This is a great question, and that's what the point of the bottom right table on the screen here is. This is temperature fault protection, and so this battery it's a smart battery. We really have an advanced communication system, an advanced battery management system here. And so this computer, if you are charging it too fast, will say, hey, if you charge above a certain rate in a given temperature range, right, it will actually open circuit and protect itself, and it will throw an error code to the it will say over or under temperature charge condition. It will throw an error code to the equipment that is charging it, so that you know that equipment had a fault. Now, again, this battery is supposed to communicate the rate that it wants to be charged, and compatible charging equipment like a Briggs Stratton inverter will slow down that charging rate. But you're absolutely right, Daniel. Having this built-in temperature protection there will prevent this battery from being damaged in the event of overcharging at low temperatures. So again, Daniel's got a whole talk that he will be giving later, or I'm not sure whether he or I will be giving that the next time it comes up, but keep an eye out for that if you're in a cold environment. We do a lot of battery sales. We have solutions for the PHI battery as well that include heating pads that can keep those batteries at optimal temperatures. And we have enclosures that we sell. We sell a lot of batteries to Alaska. We sell a lot of batteries in Canada, and they typically are using our heating solutions for these installations. Let's talk a little bit about cycle life. And Daniel, if you were sizing a system and you were sizing it just for typical battery backup, what depth of discharge would you choose?
Well, if I had a battery that I knew that was just kind of sitting there and just waiting for an outage, I would probably size the system to use all 100% of that battery. What I recognize, though, is there's so many of these energy storage systems in the market today that are grid interactive, right? These batteries aren't just sitting there. They're being discharged daily, which is why we're so proud of our 10,000 cycles and an 80% depth of discharge, is that you don't care if it's cycling because you have that 27 years of cycle life. And so if it's just sitting there, I'd probably go for 100% state of charge, or 100% depth of discharge, I should say. Yep. But if I know that I'm going to be cycling it daily, I'd probably go for something more conservative, an 80% depth of discharge. So I get the most cycle life and the most capacity at the end of life of that battery.
And really, we know that there's a mixture that happens here, right? So Daniel's saying, if you've got your batteries and you just have them for backup, discharging them down to 100% depth of discharge, taking all the energy out of there thousands of times, it's not going to create, immediate damage. But if you want the longest life out of your battery, we recommend sizing it to an 80% depth of discharge, and that's where we're expecting that 1,000 or 10,000 cycles. So if we do charge every single time, discharge every single time to 100% depth of discharge, we are only expecting a little over 3,000 cycles out of our batteries, right? And so 3,000 cycles is still a lot. That's more than you get out of a normal lead acid battery. But again, if your battery is just sitting there for that occasional power outage, it's going to take you a long time before you get 3,000 power outages that drain your battery 100% every time. And that's why Daniel's saying, yeah, if you've got battery backup, go ahead and discharge to 100% depth of discharge, completely covered under a warranty. If you discharge down to a 90% depth of discharge, we're expecting somewhere between 5,000 to 6,000 cycles out of that battery. But if you just save a little bit more of the energy in that battery, or oversize your bank a little bit and discharge at 80% depth of discharge, we're expecting 10,000 cycles. Again, that's about 27 years. It's a very long time. And so we do recommend customers that are cycling daily, like I do, to choose an 80% depth of discharge. Beyond saving more than 20% of your battery, we get this question often, doesn't really seem to give a major increase in life expectancy. So we don't see an additional return of, if you only discharge to 30% compared to 20. And so we don't really recommend any higher of a battery reserve. So keep these in mind as you're installing, depending on the customer's use. If they're intending to just do backup, maybe want to do 100% depth of discharge. And if they're doing daily cycling, we recommend that 20% left in the battery. And so I wanted to give you that background on expectancy end of life. So our PHI batteries are our simplest batteries. These are typically used for lead acid replacements, off-grid application. They're our lowest cost battery, and they still offer you this same good quality cells. But their battery management system doesn't have communication, and that's fine. And that not everybody needs to see all the details coming from their batteries. They don't necessarily want to know all of the things inside their batteries. They just want a battery that's going to be there, last a huge number of cycles, and be a lower cost to create a system for them. This is our SimpliPHI. The SimpliPHI BMS is inside the battery to protect for overcurrent. It's there for cell balancing, make sure all those cells stay balanced with each other so that you maintain that optimal capacity. And it's also there for short circuit protection. We've got a built-in breaker on that battery, an 80 amp breaker that's built in. So keep in mind, we talked about this briefly at the beginning, but a C rate on that battery, so that PHI battery is still a C over 2. So it's a C over 2 rating, which means it can be charged up in 2 hours. But that depends on your charging equipment, right? If your charging equipment is only capable of supplying a lower current than the maximum rate the battery can accept, it'll take longer to charge the battery. So the C rate of a battery is a measure of how fast the battery is able to charge or discharge relative to its maximum capacity. So it's a ratio of the capacity to the maximum charge or discharge rate. A 1C rate, of course, means the battery could be discharged in an hour. A C over 2 means 2 hours, and typical number is C over 3 for many lithium batteries. Ours are a little bit faster at C over 2. That allows you to charge and discharge a little bit quicker. Get a little more power going into the battery faster or coming out of the battery faster. So a relatively small battery bank built with our batteries can still have significant power. The PHI battery is designed for scalability and expandability. So that size of that PHI battery is 3.8 kilowatt hours when discharged at typical room temperatures. That's a small enough battery that you can start with a fairly small system. You might have a small inverter. You want to run, 3.5 kilowatts or so, and just a couple of batteries could do that for you. But it's also the ability to build a big system out of these. Daniel, we've done airport in Hawaii with, how many batteries are in that?
300 batteries, and so really able to scale up, and those were with some custom bus bars. I do want to encourage anybody, if anybody has any questions, please put your questions in the Q&A chat. It's either a button at the top or your bottom, and if anybody's going to RE+, I'm going to plug RE+ right now. Sorry to interrupt you on this talk, Nathan, but put it into the questions. Let me know you're coming, and we'll be sure to make some time to talk to you. Again, questions are highly sought after. Please put them in.
Thank you, Daniel. And expandability as well. So what we mean by expandability is here, so you can scale that system, but you might have a customer that only wants to add a couple of batteries. They add a couple of batteries, they see the value of those batteries, and in the future, they decide that they want to increase the size of that bank. Now, you do want to do this within the first few years. After 4 years, we don't really recommend combining new and old batteries, but it's a little bit of a gray area because it depends on that size of the battery bank and the typical loads that it's experienced. So there is some expandability here. You can start small and go bigger. I have 3 batteries here that are running on my home. And I imagine if I go to an electric vehicle in the coming years, as I'd like to, that I would increase the battery size, the battery bank size at my home so that I can charge during the nighttime. And so I would be storing up that solar energy. I have a lot of solar on my roof, charging those batteries and being able to discharge into the car in the evening to top that car off. Now, on sizing, again, these come in blocks of 3.8, but we can go very large on these. It does require some special considerations to balancing with bus bars. I'm showing you a picture here with 80 batteries on the left. And you can expand too on the right. I'm showing you a picture of a system that had 8 batteries, and it looks like they've added another 8 batteries to expand that capacity to 41.6 kilowatt hours. To give you some perspective here, 41.6 kilowatt hours would typically power an average home for around 80 hours. So that's a fairly big bank. We're assuming that we'd be powering at about half the power draw of a normal home. Now that depends, of course, on the home. I just got back from Louisiana and Mississippi, where I installed a few of the systems, and during the summer months, they draw very heavily from the grid because of large air conditioners that need to run in those hot, humid months. So it does depend, the amount of time that you get from one of these depends, but you have the option to expand a system if you discover that you need more backup. Some key features, again, these 5 batteries are stable. They have LFP battery chemistry. They don't vent. They don't need any maintenance. So unlike the lead acid batteries that you'd have to monitor oh, Daniel, I'm blanking on the name for the specific gravity, right? You'd have to monitor the level of the specific gravity of the battery acid inside. You don't have to do that anymore. These batteries are essentially no maintenance, right? They also have a very low self-discharge rate. If you leave a lead acid battery for a month, you'd be surprised if your car starts, or pleasantly surprised probably if your car started. But these lithium batteries, our lithium iron phosphate batteries, only have a discharge rate of around 1% per month. That's a very low rate of self-discharge. And again, you know, that gives you the opportunity to leave those batteries unattended for a long period of time and come back knowing that there's going to be some charge left in them. Another key feature is there's just no maintenance, but look at how much cleaner it looks with a lithium battery install. And this is even a fairly old SimpliPHI battery install.
Nathan, we got a question. It pertains to temperature. So Paul's asking, so the battery will only be recharging at about half charge, even at 40 degrees Fahrenheit. How to warm the battery to get 100% charge, I guess 100% rate of charge in New England winters? Yes.
So that's a good question, but I think that the answer to it is it will be charging at 20 amps, even around 30 to 40 degrees Fahrenheit. However, it doesn't take very long for that battery to heat up. I'm tempted to go back to that slide, but essentially the internal resistance of the battery is a bit higher at cold temperatures. And the reason for that is the electrolyte is fairly viscous. And that means as those lithium ions are moving through the electrolyte, they're giving a little bit more of their energy to the electrolyte, causing it to heat up. So if you are charging at 20 amps in the 30-degree Fahrenheit range, you'll quickly move that battery temperature up and have that battery at room temperature. So it wouldn't charge that at that rate for very long. So I think that's a good question. Was it Paul, Daniel, that asked?
Yeah, and we actually have another one, and it kind of pertains to this picture right here. Gail's asking, with the PHI battery being sold as a lead acid battery kind of replacement, how is the PHI battery impacted by the float charge being continued during long standby times? So does a long float charge affect the battery?
Not if you use our recommended float charge, right? So we recommend floating our batteries at 54 volts, right? So we don't want to be, and we definitely don't want to use equalized. So if you have old charging equipment that used to equalize, the point of that equalized was to provide a very high voltage on lead acid batteries to burn off that sulfate layer that could accumulate on the lead acid plates. So make sure not to use make sure not to use equalize, and then set that float voltage at our 48-volt batteries to 54 volts, or if you're floating on a 24-volt system, 27 volts. So I hope I answered those questions. And I will say one more thing to Paul. Paul, typically on our charge and discharge cycles, our chief engineer tells us that the batteries are normally in that 25 to 40 degree optimal Celsius temperature range fairly quickly. So it shouldn't be charging at 20 amps for a long time. Okay, so this is an overview of the different batteries that we offer. We've talked in depth about that PHI 3.8 battery, and we've sold many of these batteries. We've got hundreds of thousands of kilowatt hours installed worldwide for those batteries. In terms of the 3.8 battery, the AmpliPHI battery, comes in that same size, that same capacity, but this is one with that advanced closed loop BMS that offers communication ability, integrates well with our SolarX, our Briggs Stratton inverters. It's the one that I'm using on the wall behind me. If you're looking for an outdoor rated battery, a battery that has the ability to communicate, but also the ability to be mounted outdoors, be water sealed, we offer this wall mountable 4.98 kilowatt hour SimpliPHI. So we call that the SimpliPHI 4.9. It's really pretty close to 5 kilowatt hours there, 4.98. And that's an outdoor rated battery. You hang that on the wall directly.
And Nathan, that actually kind of brings up a point is
Yes.
why did we choose the 5 kilowatt hour? We have a question that says, what is the total volume in kilowatt hours at which additional permitting or AHJ approval may be needed? Have you successfully convincing certain AHJs to allow larger installations given the safer chemistry? And I'll start by answering yes. We actually have worked with New York Department of Fire to have a memorandum of understanding where we are allowed to do that. The jurisdictions around the country are all enforcing rules kind of in their own ways, just like they have in the past. And the reason we chose the 5 kilowatt hour is so you can work up to that 20 kilowatt hour threshold, which is what we see happening in Los Angeles.
That's a good point, Daniel. There's a garage limit on the size of batteries that can be installed inside in a garage or within a dwelling, right? And there are limitations in the code that prevent you from installing this within living space, right? But even within a garage, there have been restrictions to 20 kilowatt hours, and so we've sized this just under 5, so we can say we're under 20. When we have 4 of these batteries. We also want it to be expandable. We want to be able to have that smaller building block and be flexible, and that's why we chose 5 instead of, so if we had chosen a 13 kilowatt hour battery bank like a Powerwall, you could only get 1 of those in the garage. We can get 4 of these and be right up at that 20 limit. And so Daniel answered the question fairly well. So again, the PHI product line does not have that internal temperature control that the AmpliPHI does. So make sure that you pay attention to your charging equipment and make sure that your charging equipment is not going to be charging under cold temperatures. The AmpliPHI battery, of course, has that more advanced BMS that we've highlighted the features of. But if you are looking for additional protection for batteries, maybe you want that nice clean look, or maybe a plug and play option. So it's mostly assembled for you and it's really just making those final connections. Consider one of our battery cabinets. Daniel, you want to highlight these battery cabinets for me?
Yeah, so what we're looking at is our Boss 6 and our Boss 12 cabinet. And then what we can further do is take one of our Boss 12 cabinets, take out 6 batteries, and put in either a SolarX or one of our inverters. And that brings out, somebody has asked a question, is that if our battery bank is placed next to the bedroom window, is there any noise or humming coming from the 5 batteries? And no, not from the batteries, but do keep in mind that some of these Boss cabinets, I think all of them, have vent fans. So there may be a little noise coming from that fan. They're small computer fans, so they're not very loud.
Yeah, so that's a good point, Daniel. One other thing I want to stress is these are outdoor NEMA 3R rated enclosures, right? So you can put this outside in the rain. Typically, people will pour a little concrete pad. You can even buy pre-made pads. Briggs & Stratton uses these pre-made pads for our generators. And you can put these Boss cabinets right on them. As Daniel mentioned, there's a little fan. You can see here a temperature control fan that comes on and turns off if the battery cabinet gets too hot to vent out that heat. Additionally, you can't see one, but there is one here in the 12 as well. And if you have the access cabinet will have an inverter in it, and that inverter can have a fan. Now, the sound will be a little bit reduced because it's inside a cabinet, but there would be sound coming from the inverter. So coming from batteries, no. The AmpliPHI, the SimpliPHI battery can be mounted right under a bedroom window. There will be no noise. These are actually sealed batteries. And that SimpliPHI is a waterproof battery, and so you've got no noise, no fan, no humming coming from the batteries.
So if we are outside and it's cold, would it be more suitable to have the 4.98 battery, or would it be better to have one of these solutions, Nathan?
I would encourage one of the battery cabinets. And the reason for that is that battery cabinet also can be made to maintain a bit more heat. You can even put the batteries up on insulated foam. You can actually incorporate the heating pads into these cabinets. And so if you're really worried about temperature and you want to be able to get the full use out of that battery is in a cold environment, and you're going to be mounting outside, I would encourage the use of a battery cabinet like one of these. I did want to mention, that humming noise that people are typically used to for electricity. That humming noise is actually coming from the vibration of plates. So if you're near a transformer, you can hear a hum. That's actually the vibration of the plates from inductive currents in the transformer, and that only occurs with AC electricity. So you're not going to get that from a DC battery. So hopefully that answers the question. And Daniel, great point. If you are going outside, either a battery cabinet with a PHI or an AmpliPHI battery can be used, or if you want just an outdoor rated battery, you can hang the SimpliPHI battery right on the wall. But for temperature protection, we encourage the use of these cabinets. They're also so easy to install, right? You don't have to make battery cables. You can get these bus bars directly with the batteries. And when we say plug and play, we really mean it. The inverter comes pre-programmed. The batteries are ready to go. And if it's your first install, would encourage you to use one of these. You also get that nice clean look of that access cabinet. So wide temperature window. This is one reason to consider our batteries, and we don't need to use coolant with LFP battery chemistry. That's a nice thing. These are air-cooled batteries, and we don't need special cooling systems. We've got this whole product lineup of these wall-mountable batteries, and I want to highlight for you on the right side of the screen, we've got a complete ESS system. We are one of 2 companies in the entire US that makes both batteries and generators, right? The other one being Generac. Briggs Stratton has a long history of making engines and generators. We've got standby generators, and Daniel's told you he does a whole talk on that. We're happy to answer questions about that, but we've now got a vertically integrated ESS system. And the beauty of this is your warranty comes from one company. You don't have one company blaming another company, right? Saying that their equipment caused the fault, we're not responsible. We got one complete vertically integrated package. You can include a generator, you can include solar, you can include our batteries, all under a single warranty. So let me highlight this system for you. It's what I've got on the wall behind me. It's a 6 kilowatt inverter. These can be paralleled. So if you need 12 kilowatts or 18 kilowatts of power, you can parallel these units to get more power out of them. The batteries are the 4.9 kilowatt hour batteries. You can also use the AmpliPHI or the PHI battery. No problem with using that with our equipment. And this comes with an EnergyTrak control system. The EnergyTrak control system utilizes a gateway in order to get advanced monitoring of your equipment. You can do remote firmware upgrades with these. These are actually automatic over the air. You can use this to connect with Wi-Fi to the inverter and be able to monitor your system remotely. So I'll often check in on my system when I'm other places using this EnergyTrak control app. So highlighting that app has a number of features, including real-time monitoring. Commissioning process is extremely fast. Typically, after the system is installed, we're looking at 10 to 15 minutes. For me, it's less than 10 minutes. It's because I've done a number of them. Fleet management allows installers to be able to see all the systems that they've installed, monitor those systems, and be able to alert the homeowner if any changes are needed. You can remotely configure. So I could go into the system and remotely configure time of use. I could be in Pennsylvania and see that, some bad weather is coming to California. I can change the setup and say, hey, I'd like to maintain 80% of my battery just in case there's an outage. So there are great things like this with our EnergyTrak control app, and it's constantly getting better. We're constantly adding new features and new releases coming out within the next couple of weeks. We keep adding features to this, and it's going to continuously improve. Again, these battery cabinets are very versatile. They are 9540 certified, UL 9540 safety tested. They're NEMA 3R rated. You can scale anywhere from 3 batteries all the way up to 12 batteries inside these to get a huge power storage rate, 136.8 kilowatt hours. And we even have commercial and industrial division within our company. If you're looking for a shipping container, 20-foot shipping container filled with batteries, we do it, and we do custom builds of those. This access cabinet, like I said, it's a great unit. We're showing it here with the Briggs and Stratton inverter. We also have the 8 kW and the 12 kW SolarCs that we include in this. And to plug RE Plus one more time, we're going to have a representative from SolarC in our booth for a couple of our trainings together with me at RE Plus. So if you're there, Daniel, what's our booth number?
5554. And also additionally, anybody who's going to be there, we're going to be having a happy hour event. This is going to be on Tuesday, September 12th, the second day of the show, from 4 to 6 p.m. Come by the booth. We're going to have cocktails, appetizers. Come by, meet both Nathan and I, and we'll get to chat in person.
Ask us some questions. We love to get stumped because that means we have to go out and learn more. And we love learning. And honestly, we learn a lot from talking with installers and other people in this industry as well. Just to point out is that we have these high voltage batteries. We have these large batteries that come in high voltage racks. We can do this. These are server mount racks. They come with a controller. And these systems are typically for larger scale commercial and industrial projects. Daniel, what are the size of the battery banks here? And do they come in 24, 48? What's the total voltage range? What do you know about these?
Yeah, so they're 4.2 kilowatt hours each, and they're either 24 or 48 volts. And unlike our PHI and AmpliPHI and SimpliPHI batteries, these, which are run in parallel, these actually are designed to run in series. And what that allows us to do is to get high voltage battery stacks that allow us to work with inverters like the SolarC 30K, like the SolarC 60K, which you're going to see down there at RE+, and work with those high voltage battery inputs that those systems are looking for.
And typically these are used in three-phase 480 volt systems for commercial purposes. We can go up to 1180 volts with these stacks. And as Daniel said, these are run in series. There's a stack controller that's there to make sure that the system is properly maintained. And so if you're interested in larger scale applications, we have a whole division that does that. Lastly, want to plug, if you are an installer and you're looking to be part of our installer network, we have a large number of installers that are installing as part of our elite installer qualification program. So they're installing within our program. We put them on the maps. We direct leads to them. We also give $25 back per battery that's installed. And there are other promotions that we run for our elite installer program. Daniel, how would somebody sign up for this?
Yep, they can go to our website and they're on the simpliphipower.com and click on the IQ program and they can go ahead and do that. Otherwise, just get your phone out right now. There's a QR code right there on your screen. Nathan will keep this slide up for a minute. And Nathan, we had a couple of other good questions. Do you want to take them now?
Yeah, let's absolutely get into them. I love the questions.
This was a great one from Gail. Gail is saying C/2 discharge is a bragging point for lithium-ion chemistry, but some seem to need a minimum C rate that are also very aggressive, like C/2 or C/5. How does the PHI battery respond to very slow discharge rates? Or charging rates, I should say, like C/20 or C/40. So what happens if you charge it too slow?
Oh, that's a great question. I don't actually see any problem with that, and I can't foresee why other companies would. I think that I would say that if you're charging very slowly, you might not hit the bulk voltage of the inverter. So if you have old charging equipment and it's expecting to hit a 56 volts, you might not get all the way there before the charge current it drops to a level in which the absorb cycle starts. So sometimes, so that the charging cycle of a battery starts off with a constant current process until it reaches a certain voltage, or sometimes that terminates. Sometimes that terminates when the current is too low and it moves into a constant voltage process. And so depending on the charging equipment, that might be an issue. But for our PHI batteries, there's no problem in charging slowly that I'm aware of. Daniel, do you have any additional information there?
No. But if we're ready to move on, I got another a great
Sure.
question. Are any of these setups tested for EMP hardening? Now, they mentioned that the SolarArc 15K and I believe some of the other SolarArc 12K is tested. They have a customer
Well,
asking.
yes. So that's a great question. But the EMP hardened SolarArcs are special order. So the Briggs Stratton inverter is not EMP hardened, but we can get the SolarArcs in EMP hardened. So if you don't know what that means, that electromagnetic pulse hardened, right? So there are concerns that weapons might be developed that do an EMP pulse that could knock out an electrical system, and so there are some customers looking for that. And SolarArc out of Texas does make an EMP hardened inverter that we do sell. And so if you're looking for that, it is a special order. You can get that through Briggs & Stratton. And so let us know if that's something you're looking for, and we can connect you with the sales applications engineers. Daniel, other questions?
Yeah, one last one. And I'm not sure, this one's, do you recommend ferrite cores at the array for some EMP resistance? And then also asking about how many cells are in our battery packs, and if we can even share that.
Depends. Yeah, I think we can share it. The problem is I don't know the answer. I think our large SimpliPHI batteries are 27P16S, which means 27 times 16 cells in those batteries. We could share it. It's not a secret, but I'm not exactly sure on the number inside the AmpliPHI batteries. It's probably more like a 18 or 19 in parallel and 16 in series there. And it's the same number of cells in the AmpliPHI and the SimpliPHI batteries. Daniel, for the first question, EMP hardened or ferrite cores, absolutely recommend the use of ferrite cores because they're very cheap. And a ferrite core is just an iron core that goes around a conducting wire to absorb electrical pulses. And the way that happens is that the iron reacts to the current running through the wire. If you get a pulse of current, the iron kind of aligns, the magnetic nature of the iron aligns, and it absorbs that electrical pulse. And so, yes, those are very cheap ways. And many of your cords, in fact, I'm going to pull the power cord on my computer and hope the battery lasts, but many of your cords have these ferrite cores on them. And so, yes, I do encourage the use of that if you're in an area very prone to lightning. And in fact, if you look at our gateways and stuff that comes from Briggs & Stratton, they do come with these ferrite cores on the power cables to protect them.
That's it for questions, Nathan. And how do we get our NABCEP credits?
So great. Before I get to that, let me highlight one more time. If you're interested in training, Briggs & Stratton just migrated their Power Academy to a new platform, and we're going to have a lot more features on this new platform. In fact, we're going to be doing some of these webinars through that platform in the very near future. We also are increasing the amount of content on there. We're going to be able to provide some of these NABCEP credits through courses that we are loading onto the Power Academy. So do check out the Power Academy. If you haven't already signed up for an account, it's free to do so. Please go ahead and do so. I know that so far this month of September, we've added 150 accounts, and I'd love to see that closer to 500 by the end of this month. Additionally, our training calendar at SimpliPHIPower.com has upcoming trainings that Daniel or I are running, and do see us at NABCEP. If you are here for NABCEP credits, I think we're over time, so forgive us for these extra couple of minutes. Email us, training@SimpliPHIPower.com. And we will issue your certificate. Please, if your name is different from the way it appears in your email and you need it to appear on your certificate, send us your name as you want it to appear on your certificate. If you're designing a system and want some help, call our application engineers. No wait time, just 805-640-6700 extension 2. So thank you again. Appreciate your attention.
Thank you, Nathan.
Thank you, everyone.